Hello everyone. Electrification has truly entered our lives. And taking a fault I came across as an opportunity, today we'll talk about one of the most important microscopic components inside many electric motors. It is none other than the Hall sensor. We'll see what it is, why it's used, and why. Brushless DC motors have advantages over classic AC motors that operate at a fixed frequency. And in the end, we'll learn how to find faults in Hall sensors. A Hall sensor is a small magnetic sensor that is based on the Hall effect. When current passes through a conductor and there is a perpendicular magnetic field, a small voltage is created perpendicular to the current flow. In most motors, Hall sensors are digital. They output a clean 0 or 1 signal depending on whether they see a north or south pole on the magnet. Inside a BLDC motor, as brushless motors are called, Hall sensors are mounted statically on the stator and read the permanent magnets of the rotor as it rotates. In such a motor, there are no brushes to mechanically switch the current direction like in classic DC motors. In reality, it's not the coils that rotate but the magnets, and the direction change is done electronically by a controller. The controller needs to know exactly where the rotor is to send current to the correct phase. And this is where Hall sensors come in. With 3 Hall sensors placed at an electrical angle of 120 degrees, we have 6 different states that give us a complete picture of the rotor's position. This means smooth operation, proper torque at low speeds, and avoiding jerks or loss of synchronization. BLDC motors are 3-phase, but they don't take 3-phase from the mains. The 3-phase is created by their controller and at whatever frequency is needed. So the motor can have variable speed, high torque from 0 RPM, and is not limited by the 50 Hz mains frequency. In contrast, classic 3-phase induction motors work directly from the mains. Brushless too, but their speed is locked to the mains frequency. So in 3-phase DC motors, the speed is determined by the controller, not the mains. You can have high torque from 0 RPM, high efficiency, fewer losses due to the lack of brushes, less maintenance, and longer lifespan. In electric bicycles, scooters, drones, and even electric cars, these advantages make BLDC motors unbeatable. And now that we understand why Hall sensors exist, let's see how I found the fault in my own case, which was a scooter motor that didn't need new parts, just a Hall sensor. We identify the wires: red, VCC, black ground, and a signal wire for each Hall sensor. We apply 5V between red and black. We measure the signal wire of each Hall sensor to ground. We slowly turn the rotor and the signal should alternate between 0 and 5V. If it stays stuck at one value, the Hall sensor is faulty. Hall sensors are the eyes of the BLDC motor. Without them, the controller is blind and the motor cannot synchronize properly. They are small components, but they play a huge role in performance and reliability. If you know how to test them, you can save a motor that would otherwise end up as scrap. If you liked this video, share it with anyone you think it would help, and don't forget to leave your email at EKelectronics.gr to be the first to get my updates. If you're in Crete and need an electronics store, you can visit Caruso's Electronics in Heraklion. All the information is in the description. Until the next video, take care.